Okay, so let's talk about differential equations. If I gave you that the derivative is x plus 1, what would you tell me about f of x?
Half x squared plus x.
Okay, we can do that, right? Okay, well, today we're going to be working with what we call a differential equation, an equation involving the derivative, okay? Except they're not going to look straightforward like this one does here. Like here I have f prime of x equals x plus 1. Well, now I'm going to give you a differential equation, so something involving the derivative, but it's going to have both an x and a y in it, and we're going to have to strategize how to rearrange so then we can take the antiderivative. Okay? So what you are going to see, go ahead and write this down. Okay? What you're going to see is you're going to see dy dx equals a function with x and a function with y. And we're going to do something called separation of variables. If there are two functions, one involving x, one involving y, that are either multiplied or divided by each other, we can separate the variables so that x's are on one side and y's are on the other side, and that's why we would call them separable. Okay? So first thing that's different is we have x's and y's together in our derivative. Okay? Something that makes these special is that we actually have the ability to separate the x's and y's. That is not always possible, and those of you who go on more of the math track in college, you'll take an entire class called differential equations, and you'll look at the different strategies when they are not separable variables and how you solve the different types of differential equations. Okay? Did I scare you there?
That just sounds not fun.
To some people, it's one of the more enjoyable classes. So, if you're a math. Okay. So, this is how I want you to solve for separation of variables. What our goal is going to be is to separate the variables, it's all in the name, right? So that we can integrate on both sides. Okay? We're going from a derivative to a function, so we know we're going to have to take the integral, but since we have two variables, we're going to have to integrate on two sides. Okay? So this is what you're going to do. You want y and dy on one side, x and dx on the other. Y and dy on one side, x and dx on the other side. It's as plain and simple as that. Any y's go with the dy, any x's go with the dx. Whether we need to multiply or divide to get them over there will depend on the problem. Okay. Once your y and dy is together and your x and dx is together, then we can integrate both sides. We like to see equations where we solve for y. So after the integration piece, I'm going to ask you to do some algebra to clean up the equation. Solve for y. Reduce anything that can be reduced. Rearrange it to look pretty is essentially what I'm saying here. All of your answers should involve a plus c, because we're talking about going from a derivative to the equation. Okay. However, sometimes I will ask you for a particular solution. And when I ask you for a particular solution, that means you know something about the function. Specifically, you know a coordinate. Okay, so if I ask you for a particular solution, then you're going to integrate by the separation of variables, and then actually plug in that coordinate so you can solve for what the c value is. Okay. And then, of course, rewrite it with that c in there. Instead of x squared plus 2x plus c, you would write x squared plus 2x plus 1, or whatever you found for your c value. Okay, you're just going to rewrite it with that c value actually in there. Okay. No examples that we do in the next 20 minutes should be overly mind-blowing, okay? The only thing that we're really going to need to work on is seeing how to separate the x's from the y's, and then from there, we integrate. And you know how to do that, okay? But we just get to do it twice as much because we have x's and y's, okay? So let me count my examples. We have 1, 2, 3, 4 examples that we're going to do, okay? Just for this stuff. Example number 1. Okay, our first step is to separate variables. Okay? How do I get y squared with the dy? Okay, so we can multiply that y squared over. How do I get the dx with the x? Okay, so we essentially get to like cross multiply, right? We can multiply the y squared over with the dy, and we can multiply the dx over with the 3x squared. Okay? They won't always be this beautiful, but it's not going to get that much more complicated. Okay? So now we have y squared dy and 3x squared dx. We can integrate both sides. Okay? So 2 integrals now. What is the antiderivative of y squared? 1/3 y cubed. Technically, we have this plus c. And over here, we have 3x squared. Our antiderivative would be x cubed plus c. Now, do you see how we have constants added to both sides? Okay, can we combine them? Okay, now we don't know if they're equal or not. So what I'm going to ask that you do is you only put the plus c on the x side, because we know that we're eventually going to have to solve for y. But we know that there's constants added to both sides, but eventually we're going to combine them. So let's just save some time and only write the 1. You okay with that? Okay. Our last step is to solve for y. How do we do that? Okay, multiply by 3. So we have y cubed equals 3x cubed. And what is a constant times 3? It's still going to be a constant. So instead of writing 3c, just write c. Obviously, they're not the same c. We're just representing that we know it's a constant there. Okay. And then I'm going to ask that you solve for y all the way. So we would write that y is the cubed root of 3x cubed plus c. Okay.
We did it.
Eli, what do you think?
We did it. We are the best math people ever.
I am glad that you have a positive attitude.
Yes.
Okay. So that was more of our basic example. Our next three examples, I want to kind of go through some algebra that you could run into and how to work with it. Okay. So go ahead and write this one down. And maybe discuss in your pod how we would go about separating the variables.
You sure you multiplied over this and this? Yeah.
No.
Okay, how are we going to separate our variables?
Divide the y over and multiply that.
Okay, we're going to have to divide the y over. So like 1 over y dy,
Yeah.
And then
multiply the
multiply the dx over. Okay? First of all, questions about how we got there. Do you remember what the antiderivative is of 1 over y? Yeah, the natural log of y. So the antiderivative here is the natural log of the absolute value of y. The antiderivative here would be the natural log of 1 plus x. Okay. That stuff is pretty straightforward. Here's where it gets different. We need to solve for y. How do we get y equals? Oh, we got to do to the e thing. All right. So I think the easiest way to see it is if we just make each side exponents of e. Okay, so e to the natural log is going to cancel out and we're left with y. Okay, now if we have an exponent with addition in it, can we break that up? Let me write something on the board over here. What is x cubed times x squared? Because we add them together, right? So we can rewrite this as e to the natural log of 1 plus x times e to the c.
Wait, so if the first because there's the addition, that natural log can't cancel out in the second part?
Correct. Since this is tied to addition, we can't cancel this yet, but now that we have them separated, we can cancel that out. Okay? And what kind of, well, e is a number, correct?
Yeah.
So e to the c would be a number?
Yes, just
So this is just a constant. So what we can write is we can write that this 1 plus x is being multiplied to a constant. Questions about that? This right here, e to a power, will pop up quite a bit. So if you have questions about how we separated this and rearranged it, I need you to ask me. Yes?
How did you get e to the c?
Okay, so e is a number like 2.7, blah, 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 blah. So I have a number raised to a constant power. And so it's going to end up being another constant. So instead of writing e to the c, we can just write it as a constant since we know it's going to end up being a number. Does that make sense? Okay. Yes. You're playing with me. Okay. Yeah.
What happened to the absolute value?
So once they cancel out here, we don't need to worry about it. I mean, if you write it, I'm not going to make it a big deal. But especially since both sides have it, e to a power is always going to be positive, so we don't have to worry about putting the absolute value here. Okay. And then here you can write absolute value of 1 plus x, but 1 plus x will be fine.
Like, is x always going to be positive?
Yeah, and they'll probably specify that also. That x is positive. Okay. Other questions before we go to the next one? Okay. Now I want to look at examples where we actually find the particular solution. Okay, so here I have a differential equation, but then I also tell you that when x is 4, y equals 3. And notice the notation. I know it looks kind of funky. So what I'd like you to do for me at your table is go ahead and together separate the variables and just do the integration. Don't do any of the algebra yet. Do the first 2 steps. Separate the variables, take the integral on both sides.
So basically, we're just going to do a little cross multiplication. Y plus
Andre, how do we separate our variables? Okay, good. If there is any sort of coefficient, I would keep it with the x because you know eventually you're going to have to solve for y. And so having it over on the x side is going to be better for you in the long run if it's possible. Okay. So then when we take the antiderivative, we get 1/2 y squared equals negative 1/2 x squared plus c. Okay. So y squared is negative x squared plus 2 times c is still a constant. Let's just write it as c. Let's not get too crazy. Please be careful.
plus or minus.
Did you have a question, Jason? Okay. Eli, will you say that louder?
Plus or minus the square.
When we take the square root of both sides, we have to account for the positive or the negative solution. All right, if x squared equals 4, x is plus or minus 2, we have to do the same thing here.
I was asking why we didn't do it for the cube root.
Okay, yes, let's talk about that with everyone. When it is an even power, we have to account for the plus or minus. When it is an odd power, we do not. Because we can have negatives under, like, negative 2 cubed is different than positive 2 cubed, but that's not the same case for even power. Okay? Did you have a question? Okay. Anything else before we keep going with the 4-3? Okay. So this would be the solution to the differential equation, all right? Since we have an actual coordinate, we're going to continue and we're going to plug in 4-3 to solve for C. Now, technically we have like 2 solutions written in one here. Would you agree? What kind of value is our y value? Is it positive or negative? Positive. So since our particular solution involves the coordinate for positive 3, then I'm going to choose the positive radical here when I plug in 4 for x and 3 for y, because we want a positive y value as an outcome. X is 4, y is 3. So I plugged 4 in for x, 3 in for y, and we're keeping it positive since our y value is positive. Okay? So we would have to square both sides to get 9 equals negative 16 plus c. So our c value is 25.
Is the 4 not negative? Would it be positive 16?
Well, the negative is in front of the x squared, so we're going to take the square and then multiply by the negative 1 out in front. Jesse, if it looked like this, then it would be the positive 4. Okay? Okay. So our particular solution is y equals a positive negative x squared plus 25. Other questions? Before we move to our last example of this lesson. So last one. Okay, to separate our variables, the dx always has to be multiplied over. That's just kind of a given, right? But since the y is in the numerator, we are going to have to divide the y over to meet up with the dy. All right, careful here. The antiderivative for 1 over y is the natural log of y. But what's the antiderivative for 1 over x squared? One over x squared is the same thing as x to the negative 2. So we increase the power to negative 1 and divide by that power. Okay, x to the 1 over x squared is the same thing as x to the negative 2nd. So for our antiderivative, we increase the power, we multiply by the reciprocal of the power. So we are going to have to solve for y. Remember, if we have the natural log of y, we are going to have to exponentiate both sides so that the e to the natural log cancels out and we're left with y. Now my suggestion to you when you do this, I would write this as e to the negative 1 over x so you don't have to keep track of all of those negative signs. I think that would just look nicer. If you keep it as x to the negative first, it's not wrong. I just think it looks cleaner this way so you don't, especially when we go to solve here in a little bit. Okay, and remember, since we are adding exponents, it's okay to break them up this way. And then that helps us because we can write y equals c e to the negative 1 over x. It's a lot easier to plug in this way if we write c as that coefficient. Lauren, do you have a question?
We were talking about like why if you like distribute the e, why would there be a plus sign? Why are they multiplying?
Okay, so since these are exponents, when we break them apart, let's think backwards. Like if I have x squared times x cubed, we would add their powers to be 5.
Oh, okay.
Right? So it's like we're working backwards. We have something that looks like this where we have the exponents added together. So we're just going to write them as a multiplication problem instead. Okay. All right, so now we have something to actually plug in. We know that x equals 1 when y is 3. So what's our c value? Okay, so c is 3 over e to the negative first, which kind of looks gross, right? Can we write that as 3e? Okay. So now what we'll do is we'll actually plug our c value in to our equation. So if c is 3e, then we have something like this, which that also looks kind of unclean. Okay? Looks messy. So I would ask that you go ahead and use your exponent properties. Oh, I had a sneeze in the okay. To write this as 1 minus 1 over x. Because this is e to the first. So we can combine those to be that. Okay. So there's our particular solution. What I'm going to ask so that I don't have to be talking at you this whole time, we're going to take about a 10-minute intermission where I want you to try 2 problems from your homework. I don't care if they're the first 2. I just want you to pick 2 problems from that page 421. It's 1 through 17 odd. If the 10 minutes haven't gotten over yet and you've already done 2, do another one. But I want your goal to be at least 2 problems before we move on to the next section, okay? So at 10:43, maybe we'll just say 10:45, I'll round up, I'll give you a little extra time. At 10:45, we'll go ahead and transition to the next section, okay?
I think we should just power through
take notes, watch
and then watch the game at 11:15. Nope.
I think we can do it. Power through. We got it.
All right.
Some